Alright, here's the video for calculating average atomic mass and molar conversion worksheet. And this video is going to be a bit long. I do an example that is not in your homework, but it was for your lab, and just in case you want to see how that is done. So I'm going to do 2 examples and then a little extra. So we're going to do number 3. Number 3 reads, calculate the average atomic mass of sulfur if 95% of all sulfur atoms have a mass of 31.972 atomic mass units, 0.76% has a mass of 32.971 atomic mass units, and 4.22% have a mass of 33.967 atomic mass units. So, just like we did in class, we're going to set it up like this, where we have 95% times 31.972 plus 0.76% times 32.971 plus 4.22% times 33.967 AMU. So the first thing I'm going to do is I'm going to convert my percentages to decimals. So I'm going to move my decimal twice, or divide by 100, depending on how you were taught. So I'm moving my decimal twice, moving my decimal twice, and moving my decimal twice. Then here I can just multiply these numbers and add them up. So I have 0.95 times 31.972 gives me 30.3734 plus this 0.2505796 plus 1.4334074. I'm just going to add these up. And I did this because I am assuming you as students are also writing down every single number, because math teaches you that every single digit is precious. It's not. We're going to stop right here at 32.05. You can give me the 7. That would be fine also. I would take this as an answer, this also as an answer. That is fine. That would be in atomic mass units. Alright, number 5. Number 5 is confusing. Number 5 reads, alright, there are 3 isotopes of silicon. They have mass numbers of 28, 29, and 30. The average atomic mass of silicon is 28.086 atomic mass units. What does it say about the relative abundance of the 3 isotopes? So, because I am here at 28.086 atomic mass units, I'm going to say that most of my isotopes are isotope 28, and the rest I can't figure out because I don't have a percentage, but most of them will be 28, so most of the isotopes of silicon will have a mass of 28. Now, I have an example here. It's of copper. And it says copper, this, by the way, if you're good with the homework right now, you can pause it. If you would like to find out how you can solve for the percent of an isotope, then continue. Alright, so it says copper is made up of 2 isotopes. Copper 63, which actually has a mass of 62.9296 atomic mass units, and copper 65, which has an atomic mass unit of 64.9278. Given copper's atomic weights of 63.546 atomic mass units, what is the percent abundance of each isotope? So we're going to set up our equation in this form. We're going to set everything equal to 63.546, which is the mass, and then I'm going to give my 2 unknowns. I'm going to put the masses, and I'm going to say this is equal. I'm going to multiply this by x, and I'm going to multiply this by 1 minus x. So x and 1 minus x will equal 1, right? Because it'll be equal to 1. So I would multiply these. So I have 62.9296x plus 64.9278. 1 time, we're going to multiply this by 1 plus negative 1x. I'm doing this just to remember that there is a 1 right there, is equal to 63.546. Now, I'm going to move these down. I'm going to also distribute those, so I have these distributed. And I'm going to rearrange my numbers. Just rearrange right there. I'll rearrange my numbers so that I have the x's on one side and my no x's on the other side. So I end up with 64.9278 plus 62.9296x plus negative 64.9278x is equal to 63.546. So I'm going to combine like numbers, and I have 2 with x, so I'm going to do 62. I'm going to do this, and I'm going to subtract that. I don't want to run it through all the numbers. So I have 64.9278 minus 1.9982x is equal to 63.546. So I have it right there. Sorry, I'm shaking the camera. So I have this here. Now I need to get rid of my 64, so I'm going to subtract it from both sides. And there I go. I'm going to subtract 64.9278 from 63.546. I'm going to end up with negative 1.9982x is equal to negative 1.3818, and I'm going to divide by my negative 1.9982, leaving me x, and I'm going to end up with a decimal of 0.691522 with trailing digits. And I'm going to turn this into a percentage, so 69.152% of my copper is copper 63. How do I know? Because my copper 63 is the one that was given the x. And that's how you do this. We most likely will not have one of these questions, but in case you were wondering how to do this, there it is. In case you were wondering how we could actually figure out the mass of this.